Hey guys, this video I want to talk about inverse proportion. And I'm going to do that by telling you about this fence that I'm actually getting built currently. You know, like one of those paling fences. Boom, 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 boom. It's only about 40 meters long. It's along the side of my fence. And this guy told me that he would be able to do it in about 3 or 4 days. So we signed the contract. I paid him half of the money. I'm going to pay him the rest when it's finished. It's been 16 days now, and he hasn't finished. And it looks like it's going to take him another 2 days. So it's taken one guy 18 days to finish this fence. It just seems ridiculous to me. Now, if he had have hired another guy, if there had been 2 guys working there, you can guess it probably would have taken 9 days to get it done. And if there had been like 4 guys there, they would have been done in about 4.5 days. Why am I ranting about this? This is inverse proportion. Let's take a look at inverse proportion a bit more mathematically here. Okay, so we can say that 2 things are inversely proportional if y equals k over x, where k is a constant of some sort. Now, if you want to say the words y and x are inversely proportional, you can write it like this. Y is inversely proportional to x. By having the x on the bottom and having this symbol, which you learnt was direct proportion, now this says inverse proportion. So y is inversely proportional to x. Let's sketch this and see what it looks like. Let's do the fence example. So we'll jump into Geogebra and take a look. You can see here that if this is the number of people along the x-axis, and this is the number of days it takes, one person takes 18 days, 2 people takes 9 days, 4 people take 4.5, and I went all the way to 8 people take 2.25. Let's go back to where we were. And our table looks something like this. One person 18 days, 2 people 9 days, etc. Now, how are we going to find that k value? Well, it's pretty simple, really. We just need to sub some value in. It doesn't matter what that value is. So sub point, I might use 0.29 into our equation. So if y is 9, k over 2, that means that our constant of proportionality is going to be equal to 9 times 2. So k is going to be equal to 18. So therefore, the equation of the time it takes to create my fence is y equals 18 over x. And of course I can write that in Geogebra now, y equals 18 over x. And it'll fit my line here. Now, a couple of important words here. When you do an inverse proportion, that is called a hyperbola. You can pronounce that however you want to. Hyperbola, you can see it goes like this, and it's also got a matching side over here, which goes like this. Obviously, those are in negatives, which doesn't make any sense for a fence. Interestingly, this line gets closer and closer and closer to the x-axis, but it never quite touches it. And that should make sense to us because it doesn't matter how many people I employ to build my fence, it's still going to take some amount of time. They can't do it in 0 seconds. And they definitely can't do it in negative time. Now that point at which something gets closer and closer and closer and closer and closer, but doesn't touch, is called an asymptote. Okay, so 2 new words here, or a couple of things. Inverse proportion, first of all, y equals 1 on x, or y equals k on x, and then you can find k, the constant. That results in a function called a hyperbola. Goes like this on the other side. And a hyperbola gets closer and closer and closer to the x-axis, doesn't quite touch. That is called an asymptote. Getting closer and closer and closer to something, but not quite touching. Asymptote. Alright, lots of things here, guys. Inverse proportion, hyperbolas, asymptotes. Good luck.